All right, today's about trapezoids. So the essential question, how is a trapezoid different from the other shapes in this chapter? And the definition of trapezoid is that it's a quadrilateral with exactly one pair of parallel sides. What I need you to add into your picture is the parallel sides. All right, so be sure to add in those arrows on the bases, parallel sides. So the legs are the non-parallel sides. So then we have these base angles. D and C are one pair, A and B will be the other pair. So not all consecutive angles are going to add to 180, but A and D for sure will, since they're on different bases, different parallel sides. And then the other pair is B and C, when you're on different parallel sides. So because the essential question says, hey, what's different? That's one thing. Not all pairs of consecutive angles are supplementary. But this is the beginning of what is different. There's another piece that's different, and it's within the definition. In trapezoids, you only have one pair of parallel sides. The other figures that we've discussed have both opposite sides, both pairs of opposite sides being parallel. So those are two differences now that we've come across. Not all pairs of consecutive angles are supplementary, and only one pair of parallel sides. This isosceles trapezoid is a trapezoid whose legs are actually congruent. And whenever you have these non-parallel sides being congruent, some special things pop up. So if we see tick marks within the picture on the legs, we're going to now assume that certain angles are going to be congruent. So again, a difference between isosceles trapezoid and those parallelograms with angles. Notice how opposite angles are not congruent in this picture. It's like a special consecutive piece are congruent. But they have to be on the same base. So notice how if they're on the same base, they're going to be... We've been practicing how to underline important words within the directions. So in this set of directions, we're going to find the missing measures if ABCD is an isosceles trapezoid. Knowing that it's an isosceles trapezoid helps us figure out, okay, wait a second. What we just put down is, if we see this in the picture, then certain angles are congruent. But we have it in the directions. It's saying it's an isosceles trapezoid, so certain angles are going to be congruent. Let's start marking it up the same way we marked up the last one. And I'm going to use my color to mark it up. The top two angles were the same, and the bottom two angles were the same. So wherever I see this 2 arc, that's also 62. So going back to regular pencil, measure of angle A is equal to 62, but now I got to figure out what measure of angle B and measure of angle C. We don't know what those are, or we don't know what they are yet. So A and B should add up to 180. D and C should add up to 180. So if you take one, so after subtracting it from 180, yeah, both of those angles are 118. So again, I'm going to underline important words within the picture. Or sorry, not within the picture, but within the decorations. Within the directions. We've got an isosceles trapezoid. So that means the parallel sides, or some angles, are the same. Some of you are very good at visual things. 79 looks acute, so the other looking acute angle is going to be the same. So the top two will match, the bottom two are going to match. 101.